Hello mathematicians, today we're going to learn about Riemann sums. So let's look at these three graphs here. We want to approximate the area under the curve from x equals -1 to x equals 3 for the following curves. So if we look here, x equals -1 is here and x equals 3 is over here. When we say area under the curve, what we really mean is the area between the curve and the x-axis. So we have this shape right here is a rectangle. To find the area of this rectangle, we need to use the formula a equals base times height. The base here is 3 minus -1 is 4 times the height, which is 3. So the area of this rectangle, or the area between -1 and 3 under the curve, is 12. Now let's look at this curve. We're again looking from -1 to 3. What shape does this make? This makes a triangle. The formula for the area of a triangle, 1/2 base times height. So again, our base is 4, and our height now is 8. Now in this final case, what is the area under the curve between -1 and 3? Well, here, it's not a known shape. So this question is not asking to find the exact area. It's asking us to approximate the area. How do you think you can approximate the area between the curve and the x-axis? Well, Riemann had an idea of finding the area by creating little rectangles. We know how to find the area of a rectangle using this formula. So if we divide this up into little rectangles, we could approximate the area. Not the exact value, we're missing little spaces, but we would come very close. The smaller we make these rectangles, the better the accuracy. So if I made these infinitesimally small, then we would be just like line, 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 and each line would add up to the area. So we call the base of each rectangle that we have over here dx. This stands for some very, very small x. And we have our height is just the value of the function, f of x. So if we have the area, it would be f of x dx. So f of x times dx is the area of one rectangle. And if we sum all of these rectangles, this sign means sum, all of these tiny rectangles, and we make this dx infinitesimally small, so the limit as dx approaches 0, we would get the actual value of the area under the curve. And that is an integral. This sign means integral of f of x dx. So the integral finds the area under a curve. And if we have a statement like this, we would read it as the integral from -3 to 3 of x squared plus 1 dx. Now, we don't know how to do this yet, but we can use Riemann's method to approximate sums. So let's approximate this with 3 subintervals. This means the number of rectangles that we're going to use. This integral is from -2 to 4. So if I'm going from -2 until 4, and I want 3 rectangles, well, between 4 and -2, I have 6. 4 minus -2 is 6. And I want 3 subintervals, so each subinterval has to be 2. So I have between -2 and 0, and 0 and 2, and 2 and 4. I now have 3 subintervals, 1, 2, and 3. Now, we need to make our rectangles. There are different ways we can do a Riemann sum. Let's first do it with a left Riemann sum. So the left Riemann sum means the height of your rectangle is going to be the height on the left side of the rectangle. So between -2 and 0, -2 is on the left. So I'm going to use this y value to be my rectangle. So this is my first rectangle. Now between 0 and 2, 0 is on the left. So I'm going to use this height at 0 to be my rectangle. And between 2 and 4, 2 is on the left. So I'm going to use 2, go up to my curve, and use that as my rectangle. So now let's find the approximate area using this left Riemann sum. Well, our base is 2 times the height, which is f at -2. Now let's do that for our second rectangle. So we have plus, the base again is 2, times the height is the value of our function. I'm calling this f of x. So it's f at 0. And finally, we have the last rectangle. Base again is 2, and the height is the value of the function at 2. So let's simplify this a little. So we have 2 times f at -2. So if I put -2 in here, -2 squared is 4, plus 1 is 5, which you can also see on the graph, plus 2 times value of the function at 0 is 1, plus 2 times the value of the function at 2. 2 squared is 4, plus 1 is 5. So if we simplify this a little bit, we get 10 plus 2 plus 10, we get 12. That's doing it with a left Riemann sum. Let's try a right Riemann sum now. It's very similar. The only difference is we're going to use the right side of the interval. So we're still using our 3 subintervals, so we're still going to divide it up to intervals with base 2. But in this first rectangle, instead of using the left part, we're going to use the right part. So we're going to go at 0, and our first rectangle is this short. So we have, again, our base is 2, but we're using the right side, so f of 0. So that's 2 times the height here is 1. For our second rectangle, we're going to use what endpoint? Well, in our second rectangle, we're going between 0 and 2. 2 is on the right. So I'm going to go up at 2 and make my rectangle. That's now my rectangle. So again, our base is 2, and the height we're using 2, f of 2. So that's 2 times f of 2 was 5. For our last rectangle, our base is still 2. Last rectangle, the base is still 2. And the height, which endpoint will we use? Well, we're doing right Riemann sum, so we're going to use 4. My graph didn't go up that much, but you can kind of get the idea that it will stop somewhere. So let's plug it in. We want f of 4. So it's going to be rectangle here. And if we plug in 4, 4 squared is 4 times 4, 16, plus 1, 17. We're going to do 2 plus 2 times 16. And again, I got this by doing 4 squared plus 1. So if we simplify this, 2 plus 10 plus 32, we get 44. Now there's one more type of approximation we can do with Riemann sums, and that's midpoint. So if we're still using 3 subintervals, we're still going to use our 3 subintervals. And instead of using the left or the right, we're going to make our height using the middle of the interval. So if we're going between -2 and 0 for our first rectangle, in the middle is -1. So that's going to be our height of our rectangle. So we're going to have the base is 2 times f of -1, which is 2 times 2. In our second rectangle, what is the midpoint? The midpoint is 1. So we're going to use that as our height for our rectangle. So we have the base times the height, and this rectangle is also 2 times 2 for the area. So for my last interval, what is the midpoint? We're going between 2 and 4. The middle is 3. So this rectangle will have a height at f of 3. So our area is the base, 2, times the height, f of 3. f of 3 was 10. So if we simplify this, 4 plus 4 plus 20 is 28. Now, these are not all the same value because we were approximating. And some approximations can be better than others. However, if we increase the number of subintervals so that we had more rectangles, we would get a better approximation. Remember, when you're solving problems about Riemann sums, there are different ways you can approximate. Make sure you read the number of subintervals they're requesting and what kind of Riemann sum they're doing, left, right, or midpoint. Also, make sure you use the boundaries that they tell you in the problem. I hope you enjoyed this video on Riemann sums.